Hello and welcome to this fourth episode of a MiniStealth tutorial series where we're using SpriteKit and a little bit of GameplayKit to create a small roguelike, stealth-like game. And this is the fourth episode where we're going to make the player move around. But before we get into that, first a small correction on the last episode. In our MS entity class, we're setting an initial value for the position, and that's not really necessary because it's, the initializer takes care of that itself, so we don't need to do that, only need to annotate the type here. This isn't really a functional change or a bug fix, it's just a bit cleaner, I think. So let's talk about player movement. In this game, I'm going to assume that all the entities can move. So that means that everything we model as an entity can, in theory, move. Even if it's a lamppost, or it's a treasure chest, or whatever. We'll have to make sure that in our level design and in the rules, we'll make sure that things that don't make sense to move don't move. If you want to really restrict which entities can and cannot move, then you need to use components. So you could create something like a movement component and attach it only to those entities that are able to move. But for now we'll assume they all can move, and we'll do that by implementing a function called tryMove that takes a direction and a map and then returns whether the movement was successful or not. And if it's successful, also changes the position of the entity. And before we can do that, we need to add a bit of vector calculus or vector arithmetic so we can add vectors together. It's not necessary per se because you can work around it, but it's quite convenient to have. And also it's a nice way of showing how you can create additional operators in Swift. And when it comes to the cell, we need to have a property called enterable because we want to be able to indicate whether a cell can be entered by an entity or not. So, for instance, this way we can prevent an entity from walking through a wall. And it also means we can bound the player inside the level. Then we need to somehow trigger the movement, and for now we'll assume we have keyboard controls only. We'll use the arrow keys to move the player around, and we'll use the key down with event function of the game scene to capture the arrow keys and then call the tryMove function for the player. And if it's successful, then we call showWorld to redraw the map and all the entities, and we can show that the player has actually changed position. So this will be our implementation sequence. We'll add the vector arithmetic, and then we'll add the enterable property to cell. We'll add the tryMove function to MS entity, and we'll trigger movement in game scene. So let's start by adding the vector arithmetic to vector. So we'll go to vector and we'll create a new static function. And the function will be called plus, and it will take a left hand side of type vector and a right hand side of type vector. And we will return a new vector, and we will return the left hand side .x plus the right hand side plus .x, and the left hand side .y plus the right hand side .y. And now we can add vectors together. Also, I want to add a few default values. For instance, for a vector, a left vector, it'll be -1, 0, and I want one for right as well. And for up. And for down. And this will cut back on the magic values later on. So that's our vector. Then we need the enteral property for cell, and the cell enum is part of the map.swift, and we'll just create a new variable called enterable. It will be of type bool. We'll switch on the value and we'll say that if we're a floor, then we return true because we can walk over and into floors. And if it's anything else, we'll return false. This means we can't enter walls and can't enter the void. So this way we can restrict movement for the player only on those places where there are floors. So we have the enterable property. Let's add the try-move function to MSEntity. And for that we need to go to MSEntity and we'll create a new function called try-move. We'll take a direction and we'll take a map. And we will return a Boolean value. And we will calculate the new position based on the current position plus the direction. This is where the vector arithmetic comes in, we just implemented. Then if the map cell at the new position is enterable, we'll say our position is the new position. So this function will have side effect and will return true, and if it doesn't, will return false. Okay, so this is the try-move function. Because this function has a side effect, I like to add a bit of documentation. You can do that using edit or structure and then add documentation, and this creates a sort of template where we can describe a function. So we'll say move the entity to in a direction if it's enterable. The direction will be a vector and describing the where to move, and the map movement should be evaluated in, and it returns whether movement was successful. This function has a side effect. It changes position if movement is allowed, something like this. So we now have described that this one has side effects, and you can now see this in the quick help based on the on this template. So this template is parsed into this format. So it's a nice way of adding additional documentation in your source code, and it's pretty helpful, especially if you have code that you want to share with others. Okay, so we have the try-move function. Now we need to trigger movement in game scene. So let's go to our game scene, and we have here our key down with event method. This is the one that you get sort of for free from the SpriteKit template, and the cool thing is that it outputs which key you enter. So this is a great way of determining how what key codes you need for the arrow key. So if I press left, I can see that's key code 123, right is 124, up is 126, and down is 125. So let me just copy paste these ones real quick here so we don't forget them. And now we can start implementing them. So let's start with the left arrow. So this will be 1, 2, 3. What we'll do is we'll set a direction you want to move in. So let's create a temporary variable called a direction, and we'll initialize it to vector.0, and then here we can set direction to vector.left. And this is where the constants we defined come in. The right arrow, so we have a case 1 to 4, vector.right, and then we have our up arrow, that's case 1 to 6, so we'll say vector.up, and we have our case 1 to 5, so our down arrow, and our direction will be vector.down. And if any other key is pressed, we'll just print out what key was pressed, because then we can quickly find other keys later on. Now let's try moving. So we have our world that has a player and that has the try move function. We have our direction here, and we have our map in world.map. And if this is successful, then we will show the world. This redraws the world, because as you can see here, we start with clearing it and then show all tiles and all entities. If it's not successful, then we will output a string, and we'll put a string called boink at vector.0, so the lower left corner. We'll give the foreground color of the white and a background color of red. And I think this should be enough to meet our goal for today. So we have our game, we can move around, but we can't move through walls. And if you do, it indicates that you're actually pointing into the wall. So that's cool. Can't go outside. Let's just get rid of these. And I think this is our goal for today. Next time we'll start working on visibility using shadow casting. So what we're going to do is, when you look at the game right now, the player immediately sees the entire map. We're going to make it so that initially you only see a part of the map, and also line of sight can be blocked by walls and other obstacles. That way you can't, you need to sort of peek around the corner to see what's going on there. So we'll talk about visibility algorithms, we'll talk about how to show only a range, how to show what you already visited but can't immediately see anymore, and we'll also implement it using the component system of GameplayKit. So this will be the first component we're going to make. So it'll be a pretty cool episode, I think. Thanks for watching and have a good day.